If you're new to starships, you might be surprised at how far back this thing goes. Basically, there have been numerous discussions since SpaceX started. Unlike the launch system, the actual engineering and development had been primarily kept private since the start. NASA's just announced the Artemis lunar landers. To everyone's astonishment, SpaceX's massive Starship was chosen as one of 3 by NASA, along with Blue Origin and Dynetics. Understandably, this raises plenty of concerns. Some of these questions will be covered in this video. Today, we will be talking about why NASA's launch system, Moon Rocket, is dominated by SpaceX's Starship. But before we do that, welcome to our channel. Thank you all for your love and support. If you are new here, make sure to subscribe to never miss a single update from the world of space. While NASA has selected SpaceX to be a member of its commercial spaceflight operations, they are also working on its own space exploration mission. Both NASA and SpaceX are working on new heavy lift rockets to enable journeys to the moon and beyond. To go into orbit, rockets go through several stages. The rocket gets lighter and hence easier to accelerate by dumping old fuel tanks while in flight. SpaceX's launch system will have 2 stages once it's operational: the Super Heavy launch vehicle and the Starship. A liquid-fueled rocket engine works on the premise of combining 2 propellants, a fuel such as kerosene and an oxidizer such as liquid oxygen, in a combustion chamber and igniting them. To generate thrust, the flame produces hot gas under high pressure, which is released at high speed through the engine nozzle. At launch, the rocket will produce 15 million pounds of thrust, which is roughly twice as much as the Apollo rockets. The Starship will be powered by 6 Raptor engines and has a big mission bay for satellites, compartments for up to 100 crew, and even extra fuel tanks for recharging in space, which is crucial for long-duration interplanetary human spaceflight, rests atop the launcher. The Starship is designed to operate in both the vacuum of space and the atmospheres of Earth and Mars, gliding to the desired landing zone using small adjustable wings. The Starship flips into a vertical position once over the landing area and uses its onboard Raptor engines to make a powered descent and landing. It has enough propulsion to lift itself off the surface of Mars or the Moon, overcoming these worlds' lesser gravity, and return to Earth in a powered, soft landing. Both the Starship and the Super Heavy are totally reusable, and the entire system is capable of lifting more than 100 tons of payload to the Moon or Mars. NASA's Space Launch System will succeed the retired Saturn V as the most powerful rocket the agency has ever used. The latest version is nearly 100 meters tall. The launch system core stage, which contains more than 3.3 million liters of liquid hydrogen and liquid oxygen, equal to 1.5-sized Olympic swimming pools, is propelled by 4 RS-25 engines, 3 of which previously used on the Space Shuttle. The biggest distinction between them and the Raptor is that they use liquid hydrogen instead of methane. The rocket's core stage is reinforced by 2 solid rocket boosters connected to its flanks, producing a total combined thrust of 8.2 million pounds at launch, about 5% greater than the Saturn V. The spacecraft will be lifted into low Earth orbit as a result of this. The upper stage is a smaller liquid fuel stage powered by a single RL-10 engine that is smaller and lighter than the RS-25 and is meant to lift the associated cargo, the astronaut capsule, out of Earth's orbit. The Space Launch System will transport the Apollo crew capsule, which can support up to 6 crew members for 21 days, to the Moon as part of the Artemis 1 mission, a feat that current NASA rockets are incapable of performing. They are designed with huge transparent windows so the astronauts can observe the journey. It will also be equipped with its own engine and fuel supply, as well as a backup propulsion system for returning to Earth. Future space stations, such as the Lunar Gateway, will function as a logistics hub, possibly with refueling capabilities. Because the core stage and booster rockets are unlikely to be reusable, rather than landing, they will plunge into the ocean. The launch system has a higher material and environmental cost. It is intended to progress to larger stages, capable of carrying crew or cargo, weighing which could be more than the Starship. A large portion of technology which is utilized, Space Launch System, is so-called legacy equipment, meaning it was adapted from earlier missions, reducing research and development time. Earlier this month, however, a test fire of the launch system core stage was interrupted a minute into the 8-minute test due to a suspicious component failure. There was no major damage, and the Launch System Program Manager said, "I don't think we are looking at a substantial design change." We need to be clear about one thing right now. NASA and SpaceX are not competitors. If you like SpaceX, you can appreciate NASA. NASA is SpaceX's largest customer and most passionate supporter. Let us remember that. Now that NASA is investing in Starship for the Artemis mission, it may be more clear than ever. The fact that NASA is plastered all over SpaceX's Falcon 9 rocket for the commercial crew program is another confirmation of all of this. NASA and SpaceX have had a relationship since shortly after SpaceX was founded. NASA makes incredible achievements. They conduct crucial scientific research that no private company would or could ever perform. There's a lot they do behind the scenes that often goes unnoticed. The NASA Authorization Act of 2010 specified the development of a space launch system. It required to lift 70 to 100 metric tons to low Earth orbit before maturing to lift 130 tons or more. Because the Orion crew vehicle was so far advanced in development, the vehicle had to be capable of lifting it, and Congress compelled NASA to cooperate with existing partners whenever possible. NASA conducted a figures of merit analysis and limited it down to 5 potential launch vehicle configurations with 10-meter wide core diameters and oxygen-rich stage combustion engines. Some of them seemed promising. The study examined their possibilities, with affordability accounting for 55%, schedule accounting for 25%, performance accounting for 10%, and programmatic accounting for 5%. The Space Launch System will include a far more powerful upper stage known as the Exploration Upper Stage. According to NASA, launch systems will be significantly more capable because of the Enhanced Stage, which is part of the Block 1B update, although it will not see the light of day until at least 2025. Next, we'll go over the Orion spacecraft, which sits on top of this complete vehicle for the Artemis missions. Orion is a traditional triangular crew spacecraft. It is, in some ways, a larger and newer version of the Apollo command module. Although Orion appears similar, it is larger than it appears. It is a much larger vehicle, measuring 5 meters wide as opposed to the Apollo command module's 3.9 meters width. Orion also has a massive 9 cubic meters of pressurized capacity, compared to Apollo's 6.2 cubic meters. This lets Orion carry up to 6 people. As opposed to the standard Apollo astronaut complement of 3, they modified the Apollo command module for Skylab. So, which spacecraft is most likely to be the first to carry a crew to the moon? To this, we have reached the end of our video. Let us know your thoughts and suggestions in the comment section down below. We would be happy to hear from you as well. Make sure to subscribe to our channel for more similar updates. Thank you so much for watching. Until next time.